As the construction industry shifts towards sustainable and efficient design, mass timber has emerged as a competitive alternative to concrete, especially in building cores. The core of a building typically houses elevators, stairs, and utilities, playing a critical structural and functional role. In this comparison video, we'll compare mass timber and concrete cores across 10 essential criteria to understand where each material excels, where it falls short, and which might be the better fit depending on the context. Mass timber leads the way in sustainability. It sequesters carbon during the life of the tree and continues to store that carbon throughout the lifespan of the building. A cubic meter of cross-laminated timber, or CLT, stores roughly 1.6 metric tons of CO2. When responsibly harvested and thoughtfully designed for end-of-life disassembly, timber construction can significantly reduce a building's carbon footprint. Concrete, on the other hand, comes with a heavy environmental cost. Cement manufacturing alone is responsible for nearly 8% of global CO2 emissions. While innovations like carbon-cured concrete and supplementary cementitious materials are helping to lower concrete's impact, it still falls behind mass timber in terms of sustainability. Cost comparisons between the two materials are nuanced. Mass timber often carries a little higher initial material costs, but those expenses can be offset by faster construction timelines, reduced labor needs, and the aesthetic advantages of exposed timber, which may eliminate the need for additional finishes. Concrete tends to be cheaper in terms of the raw material and benefits from an established supply chain, but extended construction schedules and the need for formwork can increase total labor and equipment costs. This table, from a case study by Woodworks Atlantic, shows the costs for different construction types for a 1700 square meter or 18.3 thousand square foot mid-rise mixed-use building. Mass timber offers exceptional design flexibility through its modular, prefabricated nature. Components are manufactured with precision off-site, allowing for efficient integration of surfaces and quick on-site assembly. This approach supports adjustable layouts, easier future modifications, and a streamlined construction process. While concrete allows for more complex forms and greater heights, it lacks the same responsiveness once construction begins. In contrast, mass timber's modularity enables faster iterations and customization, making it a more flexible choice for modern, efficient design. Mass timber excels in construction speed. Components are prefabricated off-site, allowing them to arrive ready for quick on-site assembly. This streamlined process significantly reduces overall build time and minimizes site disruption. In some cases, timber building erection rates have reached 444 square meters or 4.7 thousand square feet per day for two-story structures, with multi-story projects averaging a bit more than 100 square meters or 1,000 square feet per day. Concrete construction requires time-consuming steps such as formwork, sequential pouring, and curing. Even with systems like Speedcore, which accelerate erection by incorporating prefabricated steel wraps, concrete construction is still slower than mass timber. Both materials offer solid structural performance, but concrete remains the preferred option for taller buildings or projects in seismic zones. Its superior compressive strength and stiffness provide reliable resistance to lateral forces, making it a common choice for skyscrapers and heavily loaded structures. Mass timber, though significantly lighter, about 75% lighter than concrete, has a favorable strength-to-weight ratio. It performs well in mid-rise buildings and could also be used in combination with steel or concrete in hybrid systems for taller projects. However, it often requires additional engineering considerations for structural connections and stability at greater heights. Fire performance is often misunderstood when it comes to mass timber. Despite being a wood product, it performs well in fire scenarios thanks to predictable charring, which insulates the interior and maintains structural integrity. Properly detailed, mass timber cores can achieve 2 to 3 hour fire ratings. Still, concrete is inherently non-combustible and meets fire code requirements without the need for additional treatment or design considerations. It typically offers 2 to 4 hour fire ratings and is more widely accepted by regulators and insurers alike. While mass timber's fire performance is strong, concrete's simplicity and established track record give it the edge here. Concrete clearly outperforms mass timber when it comes to acoustic insulation. Its high density and mass effectively block both airborne and impact sound, which is especially important in cores where noise from elevators or stair traffic needs to be minimized. Timber, being less dense, transmits more sound and requires additional insulation layers or acoustic treatment to match the sound insulation performance levels of concrete. For buildings where sound control is critical, concrete therefore remains the better option. That said, timber can provide advantages in internal acoustics. It often performs better at reducing reverberation and enhancing sound absorption within a room, especially when combined with suitable finishes. So, while concrete is superior for sound insulation between spaces, timber may offer a better internal acoustic experience. Mass timber provides better natural insulation than concrete. With a much lower thermal conductivity value of just 0.12, it contributes positively to a building's energy performance and helps reduce heating and cooling loads. Its low thermal conductivity limits bridging and supports passive energy strategies. Concrete, on the other hand, has a much higher thermal conductivity value of 1.60 and can act as a thermal bridge unless properly insulated. However, its high thermal mass allows it to moderate indoor temperatures when integrated with systems like core activation, delivering significant energy savings. Despite this, for insulation performance alone, mass timber is the superior choice. Mass timber still faces insurance hurdles. Because it is perceived as a higher fire risk, despite strong performance in fire tests, it often comes with insurance premiums and sometimes gets declined as a whole. As more performance data becomes available and code acceptance increases, this gap is expected to close. Concrete, with its long-standing use and predictable risk profile, enjoys more favorable treatment from insurers. Premiums are generally lower than those for comparable mass timber buildings, making it the current leader from an insurance standpoint. Both materials can be durable with the right detailing, but concrete requires less ongoing maintenance. It is resilient against weather, moisture, and pests, though it can be prone to issues like cracking and spalling over time. Mass timber needs more proactive care. It must be protected from moisture exposure to prevent biological degradation, and regular inspections are essential. However, when well maintained, mass timber can last over a century and maintain its structural integrity for decades. When comparing mass timber and concrete building cores across these 10 categories, the results show a clear trade-off between innovation and tradition. Mass timber excels in categories such as sustainability, speed, and design flexibility, making it ideal for mid-rise buildings, modular construction, and eco-conscious design. Concrete, with its structural performance, fire resistance, and industry familiarity, continues to dominate in high-rise projects. Ultimately, the best choice depends on your project scale, timeline, budget, and performance goals. As building codes evolve and market perception catches up to performance, the future may well see mass timber becoming a mainstream core solution. If you enjoyed this video, give it a like, and if you have questions or feedback, leave a comment below. Stay informed, stay inspired. TimberTalk.